Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events, held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
All right, well, welcome to another session of GOTO Unscripted. I am here with Matt Turner.
Hey.
And I'm Eric Johnson. I'm a principal developer for Serverless from AWS. But I don't know, we might talk some AWS today. I don't know. I think we're going to talk.
Yeah, little Serverless maybe.
Yeah, tell them who you are. What do you do?
So I'm Matt Turner. I'm a software engineer at Tetrate. We do service mesh SEO stuff.
Okay.
We're a vendor in that space. And yeah, I do some software engineering and some community, some dev relations. I take our stuff, I see what it can do. I try to explain that to people. I'm like, can we plug it into that system and that system? And if I can make that work, like, here's a GitHub repo full of that. Here's a blog. Here's a talk about it. So.
You do a lot of consulting then, right?
Yeah, I am. I have been an independent consultant, but yeah, I'm kind of out in the field now with Tetrate. Yeah.
Nice. All right. Well, just before we get too much, just so you know, we are coming live from GOTO Amsterdam here in. Guess where we are? Amsterdam, yes.
Yep.
So
you can tell from the
clever naming. Yes, yes.
The view.
This
is actually a beautiful room.
Yeah, this is really cool. This is the first room I ever spoke in.
Wow.
So yeah, years ago I did a talk called Attitude of Iteration, and it was about overcoming challenges. And we just, I just did a bunch of one-finger jokes and we had a good time. So it was more than that. But
Eric's talks are worth a watch. They are more than there are one-finger jokes. They're great. There's also great content.
Have you ever seen this one? Hang on. Wait. Let's see if I can do it. Okay, I want that on tape. That needs to be in the video, so it's going to get cut. So
that's going to be a GIF now.
All right. All right, so let's jump in. So tell me, you have a talk coming up.
I do.
Yeah.
This
What are you
afternoon.
talking about?
I'm talking about, I call it cloud native progressive delivery. So I'm talking about, spoiler alert, I guess, for the talk. Afterwards.
Yeah, watch this after the talk. So, yeah.
Right. I guess a lot of people talk about CI and CD, right? They talk about continuous integration, continuous deployment, and those are sort of the two stages.
Or continuous.
Or delivery. And this is the thing. Right. And people have written books on this topic. I'm not hopefully going to do like a 101, like a sucking eggs. I think the GOTO audience is a bit better than that. Like there's quite good understanding. But it's basically saying that, if you separate build from deployment, which obviously you should, and then separate deployment from release. So deploying, like getting your software, getting your container image, say, running in production is deployment.
Yeah.
And then it's sat there, it can talk to production databases, it reads production configuration, it can talk to the other production services, but it's not released if it's not getting user queries. So if you've got something like an API gateway or a service mesh that can do that more advanced traffic control, then you can have that thing running in production and you can test it. You can port forward to it, you can set some headers or whatever. You can hit it with test traffic. You can get automated, regression testing and load testing. You can start canarying traffic into it, but you can roll it back. So you're getting the most representative test because it's in prod. I've had services. We had one that just got deployed to staging. Everything looked great.
Right.
Rolled it out into prod. Crash loop just wouldn't start because somebody changed the config file format, right? And it hadn't changed. Just silly things like that, plus actually access to prod data and access to other prod services. So you can deploy like that, but and that's risk-free, right? You can then just do that, and you really do it continuously. Because so many organizations, I think, have continuous deployment. They have the machinery for it, but somebody somewhere has to go press an approve button, or it has to happen on a Tuesday. So you can deploy, and you do that, you just move that prod. Don't get me wrong, in some ways you are moving that prod to release, but you get so much more value automatically by at least wrapping deployment up.
I do a lot of speaking on, specifically for serverless, but speaking on CI/CD pipelines. And I always thought it should be CI/CD or D. You know what I mean? Because is it deployment, But anyway, that's it, And one of the jokes I say, but truly honest, is if your deployment process includes somebody's name, it's not automated. Because I can't tell you how many companies I worked as a solutions architect for a partner company, and how many times I would come in and go, tell me about your CI/CD process. Tell me how do you deploy? How do you release?
Yeah.
Oh yeah, we're fully automated. Oh, that's great. Tell me about it. Well, Bob does whatever, and then Jan does whatever. It's like, stop.
Jan's got delegation of authority. If Jan's off sick, we know who to call. So
exactly.
we're automated. We're redundant, man. Like
Jan's husband will drive down. And push the button
we go to the mood. Yeah.
So it's like that doesn't work, And so I think you're right, because I know for me, and I don't want to steal your thunder, and I won't, because you're much more eloquent than I am, obviously. Well, you're British.
It's the British accent.
Yeah, exactly.
Absolutely, yeah.
I tried a British accent. My wife just says,
say banana?
Yeah, no, I'm not doing banana. No, I did it. Oh, no.
I got it.
It's an old movie. So, well, you know what? Never mind. Anyway, yeah, so that always interests me in how people approach that. One of the things that I really encourage folks with CI/CD is when we talk about why would we go through the process of automating? Because we do have Bob and Jan, right? Yeah. But the reason is that repeatable. We know that every time it's going to go A, B, C, D, and it's not one time because Jan was sick and Jan's husband had to come down and push the button. It's going to go A, B, D, C. Yeah. And so that automation's so critical. But the interesting thing that you're talking about, and we've had these long debates about should you test in production,
right? Yeah.
Should you not? And I do think you should test in production.
I cover testing in production.
I just don't think you should only test in production.
No.
I think that's So that's where we're at. But why do you think testing in production? I mean, you kind of alluded to it, but why do you think testing in production is so important?
Because I think it's the only way you'll catch certain classes of bug. And I'm a Rust fan, right? I mean, I'm like, you should do as much testing as possible before production. And testing, people you go to interview and people say, can you draw the agile testing pyramid, right? And I'm like, there's a layer on the bottom. You've got your unit test on the bottom, I think. I literally had this in an interview once.
No way.
I won't throw any company under the bus.
Yeah.
But there's this thing on the bottom, it's like unit testing. And I know below that is we've got a compiler. If you've got a language with a strong type system, you catch a whole and a borrow checker and a lifetime checker, plug for Rust. You catch classes and classes of error down there, right? And there's the formal methods people and the Haskell people and whatever. So there's order that you should do as much as possible before production. But I think Charity Majors puts it well. You have to admit that you test in production because everybody does.
That's good.
There is zero use. I mean, what's a regression test, right? It's a test case we didn't think of. It's a unit test we didn't have.
Yeah.
User sent us input that we never thought. A user made that request? What? Why did they do that?
Right.
Okay, write that one down, store it, replay it at every version of the software because that's so crazy. We need to see what happens. So it's like testing in production is undiscovered regression tests, maybe. Is
I love
the way
that.
To put it. I just came up with that. But
no, it's good.
I like
I'm going to take credit for it, though, because I think I pulled it out of you. But so that's, the Johnson Turner.
Yeah,
so
okay.
I did remember that, So
the Johnson Turner hypothesis.
Johnson Turner, it's alphabetical. You get it. So
Turner et al, yeah.
Oh.
Yeah. I see what you're doing.
Yeah.
I know your game.
Yeah, oh, yeah. But once you deploy something, it's released out there, what's the first thing you do? You go test it.
Right.
It's like, so you are testing in production. Right. I love that.
But no, I think you're right. You've got to test. There's these classes of things you're never going to get. So the talk is talking about you can have something deployed, right? Stand in production, so you hit it with explicit test traffic. You set a header or something.
Yeah.
Explicit test traffic, so it's no users are affected, but it's testing in a representative environment. It just means that. How many staging environments have you seen that are exactly like prod?
Yeah,
right?
exactly.
They can't be by definition because they're not prod. Or you just put huge amounts of time and money. I mean, you must have seen organizations with a huge AWS estate.
Right.
And they're like, we do IAC, this is great, so I can just make another copy of prod over here for like a staging test environment. And it's costing you $10,000 a month, or whatever.
But in serverless, that changes some.
It changes some. And so, and we had this conversation yesterday, but I don't think it changes enough where we go, don't do that. Don't test in production. I do think the test in production and like you're approaching that especially with the canaries and saying, look, just the developers are seeing this, things like that. But with serverless, if you're not, I mean, I know you are familiar with serverless. If you're watching this enough familiar with serverless, Matt's very familiar with serverless. There is when you're doing release, your infrastructure as code, because you are
that infrastructure, it's the same infrastructure regardless of which account, right? Because we at AWS are managing all that, right? So it's the same infrastructure. Because that's what a lot of what you're testing is, or I guess let me say it this way. You're gonna come a lot closer to having identical environments on serverless. I won't commit to 100, although we probably are there, but I don't want somebody to come back. You said it, so I said that was Turner.
That's just the Johnson. That's just the Johnson hypothesis.
Well, that's the bus, right? So yeah, there we go. So you do serverless.
No, you're right.
Some.
I've done a little. I've not done that much. Well, okay. So what is serverless?
Okay, I was gonna say you said you had some questions.
Well, because I feel like you say serverless, a lot of people think.
I'm glad you asked. Yeah. So you say cloud native. And those aren't the same, although we fall into that. Cloud native meaning, so define cloud native to me first.
Well, that's difficult. I'm going to get this. There's people out there so much more qualified. I'm going to get roasted for this. I mean, to me, it's...
Do the 100 level.
Yeah, okay. So to me, it is cloud. I mean, that sounds silly, but like we got no data centers, we got no lead time, we've cut... I mean, this is probably getting to what you're going to say about serverless. We've cut several layers of infrastructure that we have to understand and operational burden off the bottom of the stack, right? We don't have to do physical security for a data center. We don't have to think about power redundancy, right? We've got rid of some lead times. So there's the advantages of cloud, somebody else's computer. And then I think the native part says we were born there, but the system is designed to be there. So lift and shift into cloud is absolutely a grand thing to do, right? You should get out of a data center. You should get off-prem, like out of the broom cupboard. Like lifting and shifting into an EC2 and then going from there. Like first step on the journey, absolutely valid. But to me, cloud native is something that was either, if you're lucky enough, greenfield, born in the cloud, designed and only ever run in the cloud, or something that's where the engines have been changed in flight and you've re-architected something to work in a cloudy way, right? Such that it's got lots of it's stateless as far as possible, so that you can get redundancy by horizontally scaling. You can get performance from horizontally scaling. You've got infrastructure as code, so that your environments are reproducible around the world and reproducible for tests. So all of that kind of stuff.
Yeah, and you're right. So you take that and kind of go to the next level. Serverless is just probably more abstraction. Although we say cloud native a lot with serverless as well. Just simply because we say, it's a service in the cloud rather than you spinning up a VM in the cloud and building your own service. So the service is abstracting a lot of that work away from you. And with serverless, so at AWS, you can put 100 people in a room and get 100 different definitions of serverless, right? So at AWS, we kind of, we have several tiers that we say is, first of all, or several pillars. They're not the same as tiers. Yeah, so pillars, tiers, exactly. So the first is, no management. There's no computer, no patching, you don't do any infrastructure management. The second thing is you pay for only what you use. And that's where we get into some debate. People go, does it scale to zero? Because serverless, at least a Lambda function, a step function, things like that, they scale to zero. And we, lots of services can scale to infinity and beyond. That's a good reference right there.
I like it. Yeah.
So, but we might have to trademark that one. So, but not a lot of services can come back to zero. And I think that's a critical point. However, we have some services like a Fargate or something like that may not come to zero, but they come pretty close. But they provide massive scalability.
And they can be faster as well. So a lot of the cloud native technology will get you a long way there. I can pay for what you use. I can get a Kubernetes cluster. The cluster scales based on VMs. There's many vendors out there that'll do you clever money. When your cluster is going to scale, it'll go to the spot market versus on demand versus your reserved usage. It'll do clever optimizations. And then within the cluster, your workloads, your Kubernetes deployments can scale up and down as well. So you can be pretty elastic, but you're always playing for that control plane.
You always have a base.
And you get down to one of every service, and you always pay for the control plane. Now maybe that's good enough, right? If you're huge and maybe that's fine. And there's lots of advantages, I think, to living at that level of abstraction. Because you can extend the Kubernetes control plane, you can add a service mesh, you can add all those things. So there's a lot of reasons, I think, to live at that level of complexity. But if you don't have to.
No, you don't have to, but of course you'd want to.
But as in, if you don't have the requirements for it, I would say that you want to. If you don't have the requirements for it, then maybe you could use, you know.
Well, and one of the things we talk about, I was playing with you honestly, but one of the things we talk about, and you make some good points, is when we talk, because why serverless, or when serverless, when Kubernetes, things like that, or when ECS, when Fargate. At AWS, the way we kind of look at it is, first of all, right tool, right job. Right, and we have a lot of companies, and I am a fan of this. We have a lot of companies that go, we're serverless first, but if it doesn't work in serverless, then we roll it. Then,
serverless native.
Serverless native. But companies, I won't name a bunch of them because some are US, things like that. But we have companies that say we build everything serverless first, but some workloads don't work. So we'll roll that off to containers. But the other option we have, and this leans more to what you were saying, is we have some folks that say, look, I want to be able to turn more knobs and levers than serverless gets me. And so if you look at the spectrum of compute in AWS, you start with the EC2 instance, right, where you manage all the knobs and levers. How long is it up? How powerful compute? All those kinds of things. But you patch. You do security. Right. You're up in the middle of the night when it goes down. Things like that. Then you kind of move up the stack, and you have the the EKS and the ECS, where you're managing clusters. And you still manage a lot of things, but you get some.
You're not patching operating systems and stuff.
Yeah. Well, you might be, depending on what
you
you're running.
can, exactly. But you don't have to.
But not the core, right? Yeah. So, and then you can kind of keep, Fargate, where it's a lot more is abstract out, and then finally serverless. And what we talk with folks is some of it comes down to preference. We know our app more than anybody else, even more than AWS, we being the company, right? And we want to be able to modify and turn that. We have the skill set, and that's fine. That's what we say, okay, go to EC2, go to EKS, go to ECS, depending on where you are. But we have a lot of companies that go, look, we don't want to deal with all that. We just want to put our code in, and we want to get moving really fast, proof of concept. And we don't have the skill set to patch and manage and turn all those knobs and levers. And that's really, when people say, what should I use? That's kind of one of the things I lean towards, is this is, where your definition, and of course, being a serverless DA for Amazon, I'm going to say serverless because I do believe in serverless. I'm a huge fan of it. But right tool, right job.
Right, exactly. And I believe in Kubernetes and Istio and a whole bunch of problems that they can solve. And I think that's what we look at TechTrade is if you're a slightly larger organization, your software's been around for longer, there's so much to know, and you've got the people that know all of it. Yeah. And those levers, you don't want to be patching OSs, you don't want to be doing data center physical security, but you maybe want to extend your Kubernetes, extend your network. Sure. You can write some Rust or some JavaScript, you can compile it to WASM, you can inject it into so many places with your network proxies, you can use our WAS0 product to embed that into any Golang program. So you can get that kind of control. And I think we're looking at people saying cloud native is great. If you've been born in the cloud and you've only ever done greenfield on a cloud provider, then that's awesome. But actually, if you're an enterprise with a bunch of site offices and a bunch of some stuff is still on-prem, or there's regulatory requirements, or you're multi-cloud, or any of these reasons, and you want, smart, observable, elastic compute and smart, observable, secure networking, but you've got to plug those things together across continents and across cloud providers, then you need to have that understanding, you need to have that control. And we try to take as much of that burden off you as possible. We've got our management plane, we try to take as much of that burden off you as possible and do what we're good at so that you can do what you're good at. But what you're good at has got to be running those bigger legacy systems.
And again, as a systems architect, that was a lot of the conversations we had as well, is and you said it earlier, get to the cloud as fast as you can. I mean, that's the folks that are running their own data centers. This has probably turned into more of a session than an interview. So get to the cloud. But that was one of the things we set out and said, how do we get you to the cloud? And a lot of times it's that lift and shift, like you referred to earlier.
Well, we found that we can help people with that, actually. So if you get things into a service mesh, if you have you can establish like a beachhead in the cloud, and you can then get your smart layer 7 networking, and you can actually apply it in the data center on VMs before you've gone to the cloud, before you've gone to containers. We've got ways to get that stuff really easily into the data center and into VMs and get that stuff observable and under control. Because then you try to move.
Then you start that
process.
Being
in the cloud is great. Being in the data center is better than being split across two, because then you've got like a VPN link or a whatever.
Yeah.
So if we can help with that stage, then we actually find that people find that lift and shift a lot easier. They think, oh, well, you know, my stages, I'm going to build up the tech stack, right? So I'm going to Dockerize everything, and then I'm going to put it in Kubernetes, and then I'm going to add a service mesh, and then we're like, no, actually, if you start by getting control of what really counts, which is the sort of resiliency and security of your requests.
It's the preparation for, and I think that's where a lot of companies fall, is here we are. Here's our, we don't know how it works, but just get us on the cloud.
Yeah.
But if you can come in and go, okay, now we've organized this, we know how it works. Much like what you're saying, well, let's add these layers, let's add this. We now have a good, because how many companies have you talked to where we go, it's kind of a black box to us?
Yeah.
You know, a lot of them. And so, okay, we know how it works. Now we can, you know, we talk about strangler pattern and things like that, where we say, okay, let's start pulling some of those out. And excuse me, you have that ability to start plucking those much if you know your application.
Right.
That's one of the long conversations I'd have with customers is, tell me about your application. Well,
that's the first, because that's like, oh, Dave wrote it, but Dave left 20 years ago.
Yeah, exactly.
I think, and that's the first, and that's how I describe Kubernetes to people, right? Because you can talk about, I mean, I've been on panels where you talk about Kubernetes as the new POSIX, and sure it is, it's this great, flexible, extensible API for accessing compute, and it doesn't actually have to be containers underneath, and it doesn't have to be real VMs, it can be some kind of serverless compute. But, you know, that's the very abstract, highfalutin kind of way to look at it. To a lot of people, it's like, I've got some containers, I've got lots of, I can run a container on one computer by typing docker run, right? I've now got 1,000 computers.
Right.
Kubernetes is the thing that like does that. And so what I say to people is, okay, all of these configuration, all of these different resources you can make, you're describing your application to Kubernetes. You're saying, this is what it looks like when it's healthy, when it's unhealthy, this is how it scales, I need the minimum, this thing forms a Paxos consensus, so I need a minimum of 3. You have to tell Kubernetes that stuff. And the same with Istio or any other service mesh. You tell it, oh, this is an idempotent operation, this is not. So you can retry this. So you have to know. It starts with you have to know.
Yeah, and that's where I think a lot of our companies fail in preparing for that move. How many times ago? I don't know. We don't know. And I get that because of what you said, the person who built it's gone.
Right.
We have to have it. We can't, you know, there's no end of life to this. It has to happen.
Yeah.
And so that's a painful point to them. Or it's, you know, it's on a mainframe.
Or it's on
or something like that.
Probably can't help you with a mainframe.
Interesting side note. We just had somebody, and I can't reference it right now, but I'll have to find it, who is running as a custom runtime. They're running RGP. What's the IBM? RPG?
I'm quite old. I'm not that old. Maybe.
What's that?
I'm quite old. I'm not that
anyway,
old.
it's what you run on an AS400. It's a mainframe, and they're running that code inside of a Lambda function.
Wow. I think Kubernetes was ported, I'm going to get this wrong, I think it was ported to the Z-series architecture.
Wow.
And I think it was ported to ZOS. I think you can run it, I think you can run the kubelet and all of the sort of data plane components. I think you can run on, I'm going to get this wrong, ZOS on a Z390 processor, if those are even things that exist.
Dude,
I think
what do we need that we had to do that? You know,
Who?
We don't need it. We just could do it.
It's either that or it's somebody who will never agree to be named funded that development. Like, I need this. I don't even want to talk about why we're here. Here's $1 million. Can you all just go and like do these ports for me? I'll take it away and I won't talk to you again.
It's a step backwards. You know, so well,
it's a step sideways.
So let's jump forward a little bit. And I don't know time-wise where we're at, but let's talk about. So we talked about cloud native and things like that. One of the things is serverless. I'm gonna pull us to serverless a little bit. So, event-driven architecture, which. Not all event-driven architecture is serverless, but all serverless is event-driven architecture.
Yeah.
Does that make sense?
You still so define server, because I think a lot of people say serverless.
Serverless is
Lambda.
Now I'm moving to I'm talking step functions. I'm talking Lambda functions. Chris Munns would have tackled me right there. You can't say Lambdas. It has to be Lambda functions. So yes, but
like Aurora.
What's that?
Aurora.
Aurora. There's an Aurora serverless.
Yeah.
So
So it's that kind of stuff, and that's the real, because obviously I'm deep in the Kubernetes world and whatever. Like compute networking, I got it. I want to pull the levers. I understand it.
Right.
I've got to be, database. I don't understand databases. I just want to call a database. I just want there to be. I just want there to be a network endpoint. I don't want to upgrade the database. I don't want to back up the database. I don't want to certainly patch its OS because I do not understand that stuff.
You want DynamoDB.
So to me, right. I want something. So. I can name other vendors. Like, I want a cockroach, right? Or I want a
cockroach,
spanner,
a Mongo.
I want a spanner or something.
Yeah, exactly.
Right. So it's just ambient. Like I just hit the network endpoint, and it just always works.
Yeah. So all right. So let me go back. So serverless, we talked about. You don't patch, you don't manage. You scale to zero, or it scales as you needed. We talk about pay for only what you use, and then all the security and stuff is built in, and we handle that. And in this, I'm just going to manually box it to say that at this point I'm talking about again Lambda functions, step functions, event bridge. I'm talking obviously AWS services, API gateway.
Yep.
How often do you work with EDA at all, like event driven architectures?
I haven't done too much in the cloud.
Okay.
It's something I need to get to.
Okay. And that's something that we're driving at as we're teaching folks. That's where. So this again, it kind of comes back to the knobs and levers, right? We have a lot of folks. This mentality says we don't want to do all the knobs and levers. We just want to say, this happened, do something. Mm-hmm. And this is where serverless really.
And
shines.
you think serverless is the best way to do that?
I do. Yeah, I do in this respect because I'm not one. I shouldn't have to have a server sitting out there or a cluster or anything saying, when did it happen? Listening on port 80 or port 443 and saying, when did it happen? When did it happen? Instead, I should just be able to say, that happened, I'm going to do something, right? And so, for instance, an IoT button, data saved to a database, files dropped in a bucket, things like that. So it's a different way of thinking of polling or always listening. And what we're seeing, and it allows customers, and it's also kind of a shift more, maybe this is another question for you, it's a shift more to asynchronous processing versus synchronous processing.
So I'm a big fan. And actually,
okay.
I'm quite an old guy. And you see things come around in cycles, right? So to me, like I'm thinking, I was always a massive fan of RX, the RX libraries, RxJS, RxGo, RX C#. That kind of observable base, that's asynchronous, it's pull based.
Yeah.
And those things though, they kind of, you download that library into your program and it just kind of works.
Yeah.
And then you feel like but then sometimes you need to take more control of here's the compute pool, here's the thread pool for this stage, because this is the bit that's the bottleneck or something. So we were doing that in process. And I've done a bunch of Elixir in my time. So sort of Erlang stuff. So the actor model is also a really nice kind of event-driven architecture. These tended to be on in one process on one machine. These were like monoliths. But I talk about this when I talk about microservices. And microservices are great. They've got a bunch of advantages. But they're about decoupling deployment. They're about making architectures understandable to teams. They're about distributing things. They're about getting those independent security contexts and sort of scaling boundaries and stuff. People to just talk about modularity, but we were never bad at. I mean, there was definitely some mess made, but we knew how to make the knowledge was out there of how to make a good monolith, right? You had interface-driven development, you had compartmentalization, you had DDD, right? We were pretty good at making a sort of nice compartmentalized dependency injection frameworks, all of that kind of stuff. We were quite good at doing that with monoliths. And all this event-driven asynchronous architecture, I've seen it inside a monolithic, inside one Beam VM, right? One Erlang program, or inside one massive piece of Java, right? You can have a million lines of Java that's this utterly sprawling mess with your dependency inversion problems and all kinds of stuff. Or you can have something that's actually Akka Scala, or it's actually RX Java. And it's really, really nice. So I've always been a fan of that kind of stuff.
I'm in no way saying we invented event-driven. I know it's been around.
Sorry, I wasn't saying
You're
that.
welcome.
That's the Johnson.
Yeah, just Johnson event-driven model. So event-driven's been around for quite a while. But I think there's a power. We struggle with folks kind of understanding because asynchronous versus synchronous. It's not always the case. You can have synchronous events being thrown in and responded, but most of it does kind of move to an asynchronous move. But I know that. So, kind of side quest here. The last time I did one of these interviews several years ago was actually with one of the, I don't think he was the founder, but one of the core users of Erlang.
Oh, wow.
And it was, and I'll have to come up with the name, and I know that the folks probably hanging out probably know. And
because it came out of Ericsson, right, in Sweden.
Yeah. And
It's
he
the
was
Ericsson
there.
language.
He was there when all this was happening. Ulf,
Uyghur. Okay.
you know him? They were, and then the other guy was like the genius of Elixir, and how Elixir was based on. And I mean, I can't spell. Either one of them, So
no, apologies to the Danish speakers.
Elixir is something you mix in a bottle, right? So I didn't, but it was fascinating. And I've done a little Erlang when we learned to, Erlang has a great framework for communication between devices, and we had to set up RabbitMQ.
Right.
And you had to have, I mean, literally, I'm reading docs and pushing buttons and stuff, but I got it working, and it was this event-driven kind of queuing system.
Well, within a process, everything is an actor. So you sort of take the textbook definition of object-oriented programming, I guess, came from Smalltalk. So they say that you're passing message. Think of it as passing messages between objects.
Yeah.
But of course, you're like in Smalltalk, maybe you are. In Objective-C, actually, you kind of are. But in a C# or a Java or a C++, you're making a function call, right? You're pushing some arguments onto a stack. You're changing the program counter. Like it's very coupled. It's very synchronous.
Right.
But Erlang actually says no. Each instance of an object of a class, if you want to look at it like that, each one of these actors genuinely does have like an inbox, and it has messages. That it has its own little thread. I mean, it's a lightweight thread, but it has its own little thread of execution that it'll sort of churn through the messages in its inbox.
And if it goes down.
And if it goes down, then there's actually a service discovery. If it goes down, it'll get restarted. Like if it crashes, it's isolated. It doesn't take the rest of the monolithic process down.
And that's built into the framework.
That's built. So the Beam is the name of the VM.
Okay.
Like the JVM, you can compile Java, Kotlin, Scala for JVM. Erlang was the original language. So Elixir is like Ruby for the Erlang VM. Is how I describe it. So it's a much nicer, more modern, friendly language. It just compiles to Beam bytecode. So you can look at one running like Linux process, and that can even be a distributed system and have a bunch of actors inside it. And then, as you say, you can take that. They had like a native mechanism to take that across machines, where you would run Beam. Your actors, you would have like 10,000 on this machine and 10,000 on that machine, and you'd have to set up like a message bus for them to communicate over.
I know it says in my title, developer advocate. It's because they can't fit somewhat of a developer. Become an advocate. I'm an architect. That's what I do. And that's, I'm a serviceful architect that works with service. So this has been I learned a lot from you, honestly. I mean, you obviously know deep knowledge, and I love it.
Well, I've just been around it, but I've always liked that stuff.
Yeah, well, yeah.
I've always liked those patterns.
I mean, there it is. Yeah. Big time. Yeah, it's all right.
Played with a lot of this stuff.
I'm not judging. Okay. Yeah. So, but been a lot. I love how much information is in this. This is a session in itself on just understanding a lot of thought processes in coding and development and languages, things like that.
Well, maybe I'd have to really think about it. And the session would have to be not like. What's the best way to put this? The session can't be like, this is all. What are you all talking about? Like this has all been done before. Like,
what does Turner know?
Yeah. Well, either that or like, shut up about your Kubernetes. It's just Erlang. Shut up about your Erlang.
You obviously love it.
It's just small talk.
No.
And I love this. I mean, I think I love that pattern when you talk about event-driven architecture. It's a pattern I've always loved.
It works.
So to say, and it works. And we're just, we're kind of taking it to the next level, putting it in the, in the cloud. As I say, you had all these actors in one Unix process, then you had them across machines, and now each one is a pod or each one is a Lambda function or something. Like the idea, I really loved, Elixir could do it, and Scala was very good at it. There was a DSL. You could write, because how many of those independent little communicating processes are just state machines?
Is desired state language? Is that DSL when I?
Domain-specific language.
Okay, all right,
so,
gotcha. I think desired state was Microsoft.
Oh, maybe.
There's desired. Maybe talking out my ear. There was a desired state process.
These TAs have been reused so many times. I can't remember that one. But a language that's got a syntax that's flexible enough that you can sort of extend it.
Gotcha.
So you can make like a language within a language.
Gotcha.
So in Scala or Erlang, you could just be very explicit about a state machine. Like, here is my state table. Like, what state am I in? What input did I get? do this little thing.
Got
Because
it.
you find out that so many of think about how many classes in Java, if you really squinted them, actually could be reduced to quite a simple, like, I'm in this state, I got this
Right.
event, do this, go to
Right.
that state.
Here,
Like
just move on.
just that tuple of
Simple.
Yeah, that 3
One
tuple
thing.
of where am I,
Yeah.
what came in,
Yeah,
like
yeah.
what am I outputting, where am
Yeah.
I going? Okay, that's a 4 tuple, and I think there's a 5th element actually, like the formal definition of a state machine.
Yeah.
But in these systems, you could often just write, and I think that's where something like serverless, something where we don't care about the infrastructure underneath is
Right.
is really great, because maybe something does need to be a complicated piece of compute. Maybe I've lifted and shifted it. Maybe I bought it from a vendor. Maybe it's whatever, something on an EC2 or in a pod.
Yeah.
But then, hey, this part of the system, we can just model that as a state machine. So I'm just going to write
Yeah.
it in SAM or whatever, and we're just gonna let it hum. And I don't care about any levers on that.
Yeah, yeah.
Like,
Yeah, no, and there's a lot of power in that.
Yeah.
I know we are out of time.
We are. We need
so
to wrap
yeah,
it up.
I'm gonna wrap us up. But man,
Might
like
get
you
one
said,
last pitch in for
fantastic
thanks for the
conversation.
DSL.
We are live from Amsterdam. Matt Turner,
Eric Johnson.
and Eric Johnson, the Johnson Turner Hour, and Turner after Johnson Hour. And but enjoy the time. Hope you enjoyed this. Hope you get some stuff out of this. And anything you want to say before we go?
No, it's been fun. It's the great
Yeah,
thing
it's
about
great
unscripted,
chat.
isn't it? We just sit down, we
Yeah.
see what we chat about.
Yeah.
We've kept it pretty civil. We've agreed on most
Yeah.
things. Yeah.
Oh, well, I'm going to take you out after this. But no, just kidding. No, I
off
thoroughly
camera.
enjoyed the talk.
No,
so.
it's been fun. It's been a lot of fun. Good
All right.
pleasure to speak to you, Eric.
You bet. Enjoy the rest of the conference, and we'll see you later.
Yeah. See you around.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.